Alright class, I'm going to try to show you how to use this massive chart for this massive math problem that many of you are probably choking on.
It's a lot easier than it seems.
Thanks, Sarah. Alright, so let's go ahead and look at the problem first, and let's look at the question. What is the specific heat of the metal? Alright, and that's what we're looking for. So right now, let's go ahead and mark this. We know that this is what we have to finally get to. And we're going to use this chart to get there. And basically, we have to be given everything else on this chart or be able to calculate it to be able to get to this answer. So let's look and see what we've got. So if we look right over here, we'll see that we have, starting off, a 25-gram block of an unknown metal. Well, we have 25 grams, that's the mass, that's the metal, so we're going to put 28.5 right here. And we'll just assume that this is grams and we don't have to write it every time. We'll go ahead and assume this is degrees Celsius, this is degrees Celsius, this is degrees Celsius, this is joules we've already got, and this is going to be joules per gram per degree Celsius. We won't have to write those units every time now. So let's see what we've got, what else we've got. So we see we've got a calorimeter that was used in the previous example that has a mass of 5.0. So again, mass, calorimeter, 5.0. We see that the specific heat, remember C stands for specific heat, and we see the specific heat of the calorimeter is 1.95. So calorimeter, specific heat, 1.95. And let's see what else we've got. What about the mass of the water? Yes, mass of the water. 150.0, almost messed up there. 150.0 grams. And I hope you remember that the specific heat of water is 4.184 joules per gram per degree Celsius. Well, let's see what else we've got up here. So we see that the initial temperature of the water was 22 degrees Celsius. So we come here, initial temperature, water. So we're going to put that right here, 22.0, and again that's degrees Celsius. We see that the final temperature of the water was 24.2 degrees Celsius. So that's water, final temperature, 24.2. Alright, and we can do the simple math there, 24.2 minus 22, and that's going to give us an answer of 2.2 degrees Celsius. And we can keep that number because we got 3 significant figures in each of these, so we can keep 2.2 there. Now remember, the rules of calorimetry tell us that these two values are going to be the same, the calorimeter and the water. So we'll go ahead and put 22 here, and we'll put, again, the same thing here. This will be, if the water's that, so is the final temp there. And so with the change in temperature is 2.2 again. Now, so from this, we can use this formula right here, right? The change in heat is mass times the specific heat times the change in temperature. So we're going to go 5 times 1.95 times 2.2, and that's going to give us an answer of 21.45, but we can't be that precise with our answer. We've only got 2 significant figures here, so we're going to have to round this to 21 joules. Excellent. We can find this, the heat gained or lost by the water as well. Mass times the specific heat times the delta T, or the change in temperature, and that's going to give us 1,380.72. That's way too precise. We can only have 2 significant digits here, so we're going to have to round that to 1,400 joules. Very good. Now guys, if we got 1,421 joules here, where did that come from? Well, it had to come from here. But again, we're not going to be able to be that precise because we got 2 significant figures, right? So, actually, we're doing the math there. We really could do. The least precise is here, so our least precise digit here is going to have to be 1,400 joules that were lost from the, that's going to be a negative number. 1,400 joules were lost from the metal, and they went to the calorimeter in the water. So this is a positive number, this is a positive number, and this is a negative number. Now look, we're almost here, guys. All we've got to do is figure out these missing values right here. Well, remember, equilibrium says that everything's going to end at the same temperature. So the final temp here is going to be 24.2, just like everything else. I think we're told up top that the original temperature of the metal was 151.7 degrees Celsius. If we do this math, 24.2 minus 151.7, we get an answer of negative 127.5, and we can be precise to the tenths because both of these are to the tenths, and this is a subtraction problem. Now look, guys, we have everything we need to solve the problem. Now all we have to do is, we're backwards here. We're missing what we need. Let's look at the formula again. Remember, we take Q mc delta T. If we divide both sides by mass delta T, right, that's going to leave the specific heat by itself. So now we're going to go 1400, negative 1400, divided by negative 127.5, divided by 28.5, and that's going to give us an answer of something like 0.3